A line L1, which is given below, lies on plane P1. Point A is on plane P1. Another plane, P2, is perpendicular to the plane P1. Point B and point C are on plane P2. Find the equation of intersection line of planes P1 and P2. Okay, so we are given the equation of the line L1. To start this, we need to find a point on line L1. This point can be anywhere. I'm going to choose right here, and I'm going to call it point D. We can find this point from the equation L1. So I got 1, 0, 3, which I got from here. 1, 0, 3. From there, we can find the direction vector of the line, which is 2, -1, and -2. Now we need to find the normal vector of the line, which we can find by subtracting point D from point A. So we have point D minus point A. So this would be 1, 0, 3 minus 1, -1, 3. And this would give you vector AD, which is 0, 1, 0. And we can find the normal vector of plane 1 now by taking the cross product of the direction vector by vector AD. So the direction vector cross vector AD. So this is 2, -1, -2 cross 0, 1, 0. And this would give you 2, 0, 2. And we're going to call this N1. Now that we've found N1 on plane 1, we need to find N2 on plane 2. So we can start by finding vector BC, which you take C minus B. So that is -2, 1, 2, minus 1, 2, 4. So vector CB equals -3, -1, -2. Now we can take the cross product of vector BC and the normal vector of plane 1. So that's how we're going to find N2. So N2 equals vector BC cross normal plane 1. So N2 equals -3, -1, -2 crossed with 2, 0, 2. So N2 equals -2, 2, 2. So now we need to take the cross product of N1 and N2. So N1 cross N2. And this would give you N1, which is 2, 0, 2, cross with -2, 2, and 2. This gives you the N3, which is -4, 8, 4. So now that we have the normal vector of the intersection, we can find the general equation of the planes. So the general equation is A x minus x naught plus b y minus y naught plus c z minus z naught equals 0. For the a, b, and c, we get these values from N1, and for the x naught, y naught, z naught, we get these values from point A on plane 1. So let's plug that in. So we get 2 x minus 1 plus 0 y plus 1 plus 2 z minus 3 equals 0. So now we can distribute and add, and we should get the equation of plane 1, which equals 2x plus 2z equals 8. So now we need to find the equation for plane 2. And once again, we're going to use the general equation. So for plane 2, equation for plane 2 equals negative 2 x minus 1 plus 2 y minus 2 plus 2 z minus 4 equals 0. Alright, so now we need to distribute and add again. So we should get the equation for P2 is negative 2x plus 2y plus 2z equals 10. So now, using a system of equations, we can solve this. You can do either substitution or elimination. I chose to do substitution. So let's set it up. 2x plus 2z equals 8. Negative 2x plus 2y plus 2z equals 10. And z, you add in z equals 0, so you can find these variables. So use substitution. I got x equals 4, y equals 9, and z equals 0. Now, using the equation of a line formula, r equals r naught plus vt, we can find the equation of the line intersection, which would be x equals 4 plus 4t, y equals 9 plus 8t, and z equals negative 4t. And that is your answer.